Hey guys, welcome back to SciTech Fusion. And as you know, in the last video we had discussed about the atom and its components. So in today's video we'll discuss about the gas discharge tube experiment, which is the world's most important experiment in the history of atomic physics, which later on led to the discovery of electrons. So, before the scientists knew about the subatomic particles, everyone believed that the atom was indivisible. But in 1897, a brilliant English physicist named as J. Thomson conducted a historical experiment of gas discharge tube experiment. As I said, it also led to the discovery of electrons. So, what is an gas discharge tube? A gas discharge tube is a sealed glass tube which contains some low pressurized gas, such as hydrogen, and it also contains two metal plates, cathode and the anode. The anode is the positive terminal and the cathode is the negative terminal, and also a high voltage power source of 10,000 volts is provided to ionize the gas inside the gas discharge tube, and the low pressure is created using a vacuum pump. And in this diagram you can see that we have a glass tube, hydrogen gas, two metal plates, the cathode, the anode, battery with high voltage of 10,000 volts, and also we have a vacuum pump to decrease the pressure till 10 to the power minus 3 mm of Hg. So, what exactly is the J. Thomson's cathode ray experiment? J. Thomson modified the gas discharge tube to study the nature of the rays emitted from the cathode. His setup included a sealed tube, as we discussed earlier, a sealed tube with a low pressure gas, high voltage power source of 10,000 volts connected to the cathode, which is the negative terminal, and the anode, the positive terminal. He had also applied the fluorescent coating inside the tube to observe ray movement. He had applied fluorescent screen behind this anode. So whenever the cathode ray moved from the cathode towards the anode, it would fall on this fluorescent screen and we would see bright spots on the fluorescent screen. So what were the observations made by J. Thomson? J. Thomson's observations were a beam of light was the beam of light which appeared was known as the cathode rays, and this beam of light was due to the ionization of the gas inside the gas discharge tube. His observations were a beam of light called cathode rays was emitted from the cathode and traveled towards the anode. Means it moved towards the cathode to the anode, and when an external magnetic or electric field is applied, the rays deflected towards the positive plate, proving they carried a negative charge. So in this image you can see that this is the cathode, this is the anode, this is the magnetic field, and this is the electric field. So when no electric or magnetic field are applied, the cathode ray travel in a straight line reaching this point P. But when electric field is applied, the cathode rays move towards the positive terminal of the electric field, and hence they travel to the point A. And when magnetic field is applied, they travel to the point C. This is observed using a fluorescent screen. And what were his conclusions and discovery in the discovery of the electron? Based on observations, Thomson concluded that cathode rays are made of small negatively charged particles, which he called corpuscles, and we know that these were later renamed as electrons. He concluded that these were negatively charged particles because they were attracted towards the positive plate of the cathode tube, and also they were attracted towards because they deflected towards the positive plate in the electric field. He also concluded that electrons are fundamental part of all atoms, proving that atoms were not divisible. And what are the properties of cathode rays? The properties of cathode rays are they travel in a straight line, they are negatively charged, and also they cause mechanical motion. Here in this diagram you can see that they always travel in a straight line as I told earlier, and in this setup there is a small light paddle wheel. So when these cathode ray strike on this light paddle wheel, the paddle wheel turns, which is due to the mass of the cathode ray, causes mechanical motion, proving they have mass, get deflected under the electric field. Here in this diagram you can see that they are deflected towards the positive terminal in the electric field. Hence it is said that they get deflected under the electric field. They also get deflected under the magnetic field. So let's move on to the conclusion. The gas discharge tube experiment revolutionized atomic physics as we discussed in the first part of the video, proving that atoms consist of subatomic particles. This experiment paved the way for future discoveries, including the Rutherford's gold foil experiment, which he revealed the atomic nucleus. About this gold foil experiment, we will be learning in our next video. So if you like the videos, like, share and subscribe. Thank you.